Now we need to learn how to read a scale. If you are measuring quantitatively, you obviously use some kind of instrument like the ones we've been discussing, and then you take a measurement using the scale of that instrument. So it's important to be able to read off that scale, otherwise we won't know what the measurement's telling us. The first step to reading a scale is determining what each increment means. How do we do that? We take the bigger number minus the smaller number between two parts of the scale. For example, 50 minus 40, which is equal to 10. We then divide that answer by the number of increments between those two values. So we can count these increments, and if you count them, you'll see there are 10 of them. There's a 10 millimeter difference between 40 and 50. And there are 10 increments representing that difference. And so, 10 divided by 10, each increment stands for 1 millimeter. This is a very easy example. Let's take a bit more difficult one. B. Here we have 4 milliliters and there's 3 milliliters. The difference between that, of course, is 1 milliliter. And there are 5 increments between them, which are representing this 1 milliliter difference between them. 1 milliliter divided by 5 increments gives us a fifth, or 0.2, which tells us that each increment stands for 0.2 milliliters. So that there's 3 milliliters, that's 3,2, 3,4, 3,6, 3,8, 4. 0,6 minus 0,4 is equal to 0,2. So the difference between that value and that value is 0,2, and that is represented by 10 increments. Go and count them and you'll see there are 10 of them. So each increment stands for 0,2 divided by 10, 0,02. So that's 0,4, 0,42, 0,44, 0,46, 0,48, 0,5. 0,52, 0,54, 0,56, 0,58, and 0,6. The last example, 0,02 minus 0,01 is 0,01, and there are 10 increments. So each increment stands for 0,01 divided by 10, and that's 0,001. All right, once we've decided what each increment stands for, then we can count how many increments there are from the lower of the two numbers between which our line is. So in A, we count from 40, 40 being the smaller number of the 40 and the 50 that we see there. And we see that there are 5.5 increments from 40 to where our measurement is. And once we know that, we need to multiply that by what the meaning of each increment is. So in A, each increment stands for 1 millimeter, and there are 5,5 of them from 40 to where our measurement is. So that stands for 1 millimeter multiplied by 5,5, which gives us 5,5 millimeters. Then all we need to do is add that value to that lower measurement that we were counting from, 40 in this case. So that measurement there is 45,5 millimeters. What about B? So we've already determined that each increment stands for 0,2. We count how many increments there are from the lower number, 3, to our measurement. And we see there are 2 increments, each one standing for 0,2. So all of them standing for 0,2 times 2, 0,4. Which tells us that our measurement is 0,4 milliliters more than 3,4 milliliters. Don't forget to write the unit as well, milliliters. We can't just write 3,4. 3,4 what? 3,4 apples? No, of course not. 3,4 milliliters. In C, we count how many increments from 0,4, the smaller of the two numbers we see there, and we see it's 1.5 increments. 1.5 increments stands for 0,03 on the scale. 0,02 times 1,5 equals 0,03. Therefore, our measurement is 0,03 more than 0,4. In other words, 0,43. The last example, we've seen that each increment stands for 0,001. The smaller of the two values we see here is 0,01. Our measurement is 7 increments away from that. That means that it is 0,001 times 7 more than 0,01. In other words, it is 0,007 more than 0,01. So our reading is 0,017 milliliters. Now you try to answer these questions on your own. Give the measurements, pause the movie while you do this. And once you've done so, unpause the movie and look at the answers.